All right, folks, video 2 of the week is data tidying. So once we get our columns changed, we've renamed columns, made those things made sense, now we need to get our data into tidy format. tidyr is the tidyverse package that we're going to use for this. Again, we remind you, each variable is a column, each observation is a row, and each value is a cell, just like this visual. So our first step when working with data tidying is examining your data. Ask yourself, okay, does each column only represent a single variable? Is there any column that I need to split? Does every observation only take up one row? Do I need to condense things so that this is the case? Does each cell contain only one value? So when you're working with a new data set for your final or in other situations, these are the questions that you should be asking yourself as you first start exploring your data. So I want you to look at these data sets. They're from the book. Pause the video and think, what data set is tidy? When you're ready, click play, and I'll move to the next slide. So go ahead, check out Table 1, Table 2, and Table 3. If you guessed Table 1, you are correct. So Table 1 is the only tidy data that we have in this example. The reason that the others are not considered tidy, Table 3 has two values that are separated by that slash under the rate column. So rate has two different values, that means it's not tidy. Table 2 has two different variables under the type column. So Afghanistan 1999 is split into two different rows, cases and population. So that's not tidy. Table 1 is tidy. Every column represents a different variable, so year, cases, population, and country. And we don't have Afghanistan 1999 split across two rows. Now, we do have two rows of Afghanistan, Brazil, China, and etc., but the reason that we do is that these represent two different years. So this is still considered tidy. To create tidy data, because again, most of our data sets that we work with, they're not going to come pre-tidied. To do so, you're going to use pivoting. Pivoting is going to allow you to change your data format without changing any of its values. There's two different types. The first is pivot longer, in which you take you move from having columns to having more rows. And for the arguments for this, you need to have columns, names to, and values to. And then pivot wider. That's the opposite, where you have multiple rows that represent the same thing. We need to instead have more columns. This, you need to have the arguments names from and values from. I'm going to go ahead and switch to my R screen, and we'll work through some example code. Again, as I've said, all of this code that's used in this week's lectures is in one document, Data Transformation, Tidying, and Import under week 2. So in our data tidying section, this again is going to use functionality from tidyr. First, I'm going to pull in the example tables that we had just in our slides from the textbook. Now, I don't have every single value. I've only created the ones that I could see in the table. And what I've done is I've just used the data frame function, and I've created columns for each of what I saw in those tables. So let's read in Table 2 and Table 3. And remember, think about why those tables are not considered tidy data. I'm trying to get out of my play button is right in front of where I need it to be. There we go. Okay, so Table 3. Let's start with fixing Table 2. Again, we look at it. Here we have cases and population both under the type column, but those are two different things. Cases and population mean something different. So for this, we're going to pivot this wider. It's a very simple command. I name the new data frame, so Table 2 wide. I open up Table 2. I use my pipe to say then, and then pivot wider names from type, so that's this initial problematic column, and values from count. That's this one here. So I run that, and then I want to inspect my new data frame by just typing its name again. So let's look. Table 2 wide, great. Now cases and population each have their own columns. Looking at table 3. So again, table 3, here we have rate. It has 2 different values within it. What I'm going to do is use something called separate wider delim. We're going to cover this a bit more in the next week, but just so you know how it works now, what I'm doing is I'm saying, hey, I know that I need to break that column. I need to break the column, and the separator between the 2 values is that slash. So I use separate wider delim. Columns, I tell it, okay, this is the rate column. That's where the function needs to focus. My delimiter is this slash, and the new names are cases and population. If you want to know more about this function, you can uncomment this line, look at the description. So this just splits a string into columns, and when I run this, here we go. So let's look at table 3 wide. Now cases and population are split. The same thing, pivoting wider, it's just I had to use the string command because of the nature of the data. I'm also going to pull in an example not from the book. So this uses the data called FAO stat livestock. And if you notice, my file path, I'm reading in just from my data folder. So I have my nice directory that we created the very first week. I've added in a new folder, and this folder is home to all of the different data that I've used so far in the course. So I tell it, okay, I have my working directory. It's been set to my 601 summer 24 session 2 directory. Within the data folder, let's read in this livestock CSV. Great. If you want to view it, all you have to do is type that command view, or again, you can just click on it in your environment. And so here we see domain code, domain, area code, area. And so this is just the value of different livestock throughout different years in different countries. So we've got a big old data set. We've got 82,116 observations of these 14 variables. So I've already looked at this data. I've decided that I'm going to remove the code columns and the flag columns because they don't really tell me anything and I don't need them. But you'll see, again, I'm creating a new name for this because that way I'm not editing the initial data. So here I use the select command that we learned earlier. Select anything that doesn't contain code or flag. So let's look at livestock reduced. We went from 14 variables to only 7. So now, okay, we've got domain, area is the country, element, item, year, unit, and value. So domain, element, and unit, they look like they're the same thing, just repeated over and over. And just, if we scroll through, it looks the same, right? Like we see that cattle, asses, whatever is shifting, but not a lot going on over here. Now, I'm not going to scroll through 82,000 rows. So what I can do is use ndistinct to check what are the distinct values in these columns. So number of distinct values in domain is 1. That means that domain, all it says is live animals. And same with livestock. If I want to try unique, this will tell me the actual single value. All it says is live animals. So I can remove that. Another way that I could calculate is this, is it just one value, is using summarize. So here I say open up livestock reduce, then summarize, using all the same things. The only thing different is I can have number of units. What's the number for domain, element, and unit, rather than typing that out individually for each column. Here we see, okay, everything's calculated as 1, so let's go ahead and just select everything but those. So now we've gotten down to only 4 variables: our area, our item, our year, and our value. And these are what our analysis is going to look like. When it comes to your Quarto documents, typing in head is helpful for your audience member, me and the TAs, to also see what your data frame looks like. So there's a few different ways that you can check this. I'm always checking in some way, using head, using view, just clicking on the data frame to make sure that my changes are what I wanted them to be. Now what we can do is we can arrange by year. So here we arrange, so we've got Afghanistan asses, camels, cattle, and goats, horses, mules, sheep, etc. for 1961. And then we move to the next country. We have asses, buffaloes, cattle, etc. for 1961. And this goes on and on. But items seems pretty important here, right? Rather than just item, those individual animal types seem like they should be their own variable. So this is where I'm going to use pivot wider. I'm going to take livestock and I'm going to take the names from this item, the asses, camels, etc. And I'm going to take the values from the value column. So let's go ahead and run that. Let's look at what the data looks like. So now our wide has 11 variables, but 13,000 observations in juxtaposition to 82,000. So now each of those columns represents something different. And again, you can use dimension, you can check up here, you can also use the dimension command to check, okay, it went from 4 columns of 82,000 rows to 11 columns of 13,347 rows. And we see here, so for example, in Afghanistan in 1961, there were no buffaloes or pigs being sold. And so what R has done is it's automatically filled in NA values there. We can also pivot longer. I'm pulling this example from the book. I'm using the Billboard data set. Again, you can always use the question mark to check out what is in here, and I encourage you to do that with any data set that you pull in from a library. So we know that this data set has rankings for the Billboard Top 100 in the year 2000. It has artist, track, date, and weeks. So when we look at Billboard, we have so many week columns, right? We have week 1 to week 76. That's a lot. And so what we can do is pivot longer so that week is just one variable, and then we can plot it over time. So here, similar, I'm going to call this Billboard long. I open up Billboard, then I pivot longer. I want to pivot any of the columns that start with week. That way I don't have to type week 1, week 2, whatever, all the way through 76. I just use starts with. The names are going to turn into week, and the values are going to turn into rank. So let's run that, and then use our head function. Great. So now we see week 1, week 2, week 3, whatever. Now what we can do is we can group by week, we can sort by ascending value, and we can slice to show the top artists from each week. So we take, I'm creating a new data frame called Billboard rank. We're taking Billboard long, grouping by week, slicing so that the very top, we just see the top from that group, and then we're just relocating artist and track, so that way they're at the very front and we can see them easily. And that's how pivoting can help us with getting statistics and with getting an understanding of our data. Last, in our next video, we will go over data import as well as an example that pulls everything together.